Okay, hello everyone. How are you? Am I audible? आवाज आ रही है मेरी? चलिए शुरू करते हैं सेशन, बाकी लोग जुड़ते रहेंगे धीरे धीरे. लेट स्टार्ट द सेशन एंड very good afternoon everyone. I hope all of you are doing well. Today we are going, as I said earlier, that as I announced earlier, that we are going to start data structure sessions from Monday, and this lecture will be again this week will continue, and each day we have a separate topics that we are going to cover. Today is the first lecture of the stack data structure. Okay, so what is the recap? So what we have done here last day was I talked about 1D array, one dimension array. Okay, 1D array I talked about. Also I talked about pointer arithmetic. Okay, pointer arithmetic, and I told you that how we can interpret this bracket operator, where I can open with this logic, and here the logic of plus belongs to pointer arithmetic, I plus a, and finally I of a. Okay, so this all four equations are same. Okay, so I hope everyone is ready for today's session. Today we are going to talk about few things, which is a stack as ADT. We'll talk about stack as abstract data type, ADT. And when somebody say that it is an abstract data type, it is the, let's say the definition, the linear definition, and the function without implementation. We are not bothering about implementation. When somebody will say give the abstract level, in abstract level means without implementation. Okay, without implementation. So only we'll talk about without implementation, what is possible over here. We'll also talk about today one of the important part of this is called as expression. Okay, so we'll talk about expression, and we'll deal with three types of expression. I hope I'll finish it: infix, prefix, and postfix. Okay, and we'll see only the gate approach, the semester approach, where we can use a stack for conversion, which is more important semester point of view, but not important from the gate point of view, though I cover both of the process in the class. Okay, so there is no issue, but right now we will concentrate on only the stack, the precedence method here. Okay, so I hope you are ready to begin, and let's start with this question that we are not going to solve. This is beyond this data structure. So now let's talk about stack as a LIFO data structure. Okay, so now let's talk about stack. Now what is the idea of the stack? The stack is a linear data structure. Okay, what is the property of the stack? The stack is linear data structure. Linear data structure. Okay, linear means one element will be logically related with only one element. Okay, that's sort of the relationship, like train ka dabba. Okay, train, one behind one dabba there is only one dabba. After that, forward also and backward also. Okay, so moving forward only one dabba and backward also one dabba. So that is basically called as a linear data structure. Our folder structure. Okay, I hope every one of us uses Windows. So folder, within a folder there can be multiple folder, right? Within a folder there can be multiple. Parents can have multiple children. Okay, so that relationship, multiple relationship, logical relations, that is basically non-linear relation. So it's a linear one, train ka dabba. Okay, now it's a one-ended stack is a one-ended data structure. The stack is one-ended data structure, one-ended data structure. So only one-ended means that other places, random access, anywhere I can read, anywhere I can, no, not allowed. You have only a single end of the data structure, and whatever operation, insert, delete, insert and delete mainly, which has to be performed only on that particular end. Now because of that, stacks based on the principle of last in first out. Last, not fair, last in first out. Unfair, last in first out. Unfair data structure. No syllabus change, no syllabus change, forget. Now, so now the announcement has already been done, and you also get ready for the challenges of GATE examination. Since the announcement has been done and within 15 days the website will be released, so I think now it's a high time that you get serious, leave everything aside, focus on your goal, up the tempo, that means timings, syllabus completion, all test, all you should start focusing on. Okay, all you should start focusing on. Last in first out, and that is a LIFO structure. Stack, we mainly we perform two operations on the stack. Okay, we maintain an index called top. Okay, we maintain an index called top, where next operation is performed. Okay. There are two operations in the stack. Which protocol is removed? What protocol removed? Application layer. Is it so? Wait. Let me see. Wait. Let me confirm it. IIT Madras. IIT Madras 2026. Just 1 minute. Examination. Just 1 minute. Just give me 1 minute. Get paper, 2 paper, important at home, examination city. Opportunity download. Browser. Yes, browser we can download. Syllabus, I think it should be just 1 minute. 1 minute. You want to see the syllabus? Let me check. Just wait a minute. Let's see. Let us analyze the syllabus here only. PA of technology. Wait a minute. You will get a session for that if there is a change. Okay, look at here. Okay, look at here. If you possible to window Chrome, no, we have Yes, now you can see the syllabus. So proposition logic, first order, set relation function, partial order, lattice, monoid, group, connectivity, matching, coloring, no change, Lie matrix, determinants, eigenvalue, eigenvalue decomposition, system of linear equation, vector space, anyway it is not there, LU decomposition, limit, probability, uniform, fine. Digital logic, design and combination circuit, where is that you are saying? Fake news. Algebraic technique, Boolean algebra and minimization, algebraic technique, K-map, tabular method, design and combination sequential circuit, number representation, fine. Architecture, instruction set, addressing mode, control unit, hardware, microprogram, memory interface, performance, cache memory, mapping, same. Programming is here, recursion, stack queue, linked list, tree, binary search tree, binary heaps, graph, same. Searching, sorting, hashing, asymptotic, worst case time, algorithm design technique, greedy, dynamic, graph traversal and tree shortest path, same. Graph traversal, theory of computation, expression, finite operator, context push on regular and context free language, pumping lemma, same. Lexical, syntax, runtime, intermediate code generation, local code optimization, data flow analysis, liveness analysis, same. Operating system, same. Databases, same. Yeah. This is I think we have a principle of performance matrix and data link layer is there, distance vector routing, IP4 segmentation, TCP congestion control, API. I think network has some impact. This syllabus was not that, this syllabus was screen off. It is visible, it is visible. Why it is you're saying screen off? Network has some changes, I can see. There are some changes in the network part. Application, API, socket and API, DNS and this. Network has changed. Yes, yes, there is some changes are there in network, especially in network. अच्छा टेबुलर मेथड नहीं था, ठीक है ठीक है ठीक है ठीक है. Yes, so I think two changes are there. I think Mithesh is correct. Let's not doubt his assessment. Mithesh is correct. Tabular method was not there, and there is a major change in, I think, CN. A major change in CN, I guess. No issue, no issue. Fine. Chalo, ठीक. So there are major changes in CN. I think they have reduced the syllabus of computer network. Okay, let's see how much it impact in this, but it was very big syllabus. So they have removed some content of CN. Let's see, and one change over there. Okay, tabular method. Okay, where the operation is performed. Now the operation that is performed here is fifth is push and pop is performed. Push and pop. Okay. Now let us start. Now, so now we start with the empty stack, and there are many implementation possible, but in this implementation, let's hope that this is an array implementation. Linked list also can be used for doing this. So let's start with array implementation, and in this case, let's say top is equal to -1. Okay, top is equal to, we start with -1, C implementation. Okay. Now when I say push 1, okay, push 1, when I say push 1, so top will become 0, okay, -1 to 0, and we push the element. Okay. Now in this we will perform the value push 2, okay, push 2. So now 0, top will become 0 plus 1, and that will become 1, and it will be pushed. Okay. So now if I say in this push, if I say 3, then the third element will be pushed, and index will be 0, 1 and 2. And in this say I say push 4, if I say perform the push operation, then it will be performing the 0, 1, 2, 3, 0, 1, 2, 3. Now anywhere you cannot, anywhere you cannot, hello everyone, hello Pranav, sorry. Anywhere you cannot delete this, anywhere you cannot perform the delete operation. The deletion should be performed here. So now when I say pop operation over here, so it will go to the top index and remove from 3. Okay. So now what it will do, it will first remove the element. Let's say if I am storing in data is equal to, it will remove from top, and then it will do top is equal to top minus 1, top is equal to top minus. So 4 will be deleted, it will, top will become 0, 1 and 2. Okay. Then again if I say pop operation, okay, then 3 will be deleted and return. Okay, 3 will be deleted and return. So 3 will be deleted and return, it will become 0, 1. And then if I say again delete the 2 do over here, again perform the pop and again perform, then it will be deleted. Okay, so now you feel this, index is not important right now for you. Okay, index is not important for you. Understand that how the operation is being performed, how top element is being removed. So now here insert 0, insert 1, so top, push 1, so it will be pushed, push 2, it is pushed, see it is increasing, push 3, it will be pushed, push 4, it will be pushed. Now let us say perform the pop, so 4 will come out, top will become 3, 3 will come out, top will become 2, 2 will come out, top will become 1, and again say you pop operation, it will remove from the stack. It is an empty stack here. This is the logical property of the stack. Okay, this is the logical property of the stack, and that's why we call it as property of stack, and that is the reason that we call this as a last in first out. Okay. Now very quick testing right now here in this cases. Answer it. Very quick testing. What will be the answer for this question? What will be the answer for this question? If syllabus has been reduced, then it is a very good news actually. Though digital is having something added up, but if syllabus of this is removed or CN, it's a good news. Your headache will be less. Let me give you a page. Let me give you a description of it. Let's compare the syllabus. I think that will be better to compare the syllabus, because there is a major change I can see. Give me 1 minute. I think this is important. Just 1 minute. Okay, B is the answer for this. Look at here once about the syllabus. Okay, let us see one time the CN syllabus. I think anyway you will get more updates on this, but yes, it is something that we have to adjust. Okay, come here once. Basic switching, packet and virtual switching and performance matrix. Virtual switch, data link, acha, fine. Performance matrix, this is one thing added. Okay. Protocol stack, basic of packet and virtual switching. So ये तो that this is same, basic of virtual switching and performance matrix. This is new. Data link layer, framing, error detection, medium access control, Ethernet bridging, routing protocol, shortest part. Data link layer, error detection, medium access, Ethernet distance vector, and link state routing. So error detection is there, medium access control is there, Ethernet is there, Ethernet then bridging, Ethernet bridging, so only Ethernet is there. Then routing protocol, shortest part, distance vector, and state link state. So same. IP4 fragmentation and IP addressing, तो fragmentation, IPv4 fragmentation, CIDR network and NAT network address translation, IPv4 CIDR, basic of IP support protocol is not there. Okay, basic of IT protocol is not there. Network address translation is there, flow and congestion control. Okay, transport layer, flow and congestion control, so that is there. And socket API, socket API was socket API, no, socket API, sockets are there, socket and API, socket APIs are there, and this DNS and only HTTP protocol is there. I don't think so major changes are there, almost same, it is almost same, I guess, almost same. I am good speed, so almost same. Yeah, something has been removed, like here I can see only two part, that is it is saying that it is a very gist one, but this basic IP support protocol has been removed, and DNS and HTTP is there. Most of the application is not there here in this case. Chaliye, no issue. So this is some major changes, is it? No, not a major change. Chaliye. So now here in this cases, let's come back to this 10 20 10 20 pop, so 20 will come out. Then again you say push 10, yes, push 20 20, then 3 times pop, so 20 10 10, so 20 10 and 10, fine, 20 10 10, then push 20 and then pop. Okay, so 20 20 10 10 20, 20 20 10 10 20, B is the correct answer for this. B is the correct answer for this. Now let's have one more question related with this. Now suppose we perform following operation on stack. Okay, so let's start with this, push 10, push 30. Okay. Now push pop plus pop, then push 40, then push 60, push 40, push 60, push 90, then push, pop minus a pop. Okay, first pop and then second pop. Pop plus pop. Okay. Then x is equal to pop and y is equal to pop. What is the value of x plus y? Okay, straight away new question. Answer this question. What will be the answer? Suppose we are performing following operation on the stack. Size is, let's say size of the stack is 10. Size is 10. Doesn't matter. Size is 10. Doesn't matter here in this cases. But yes, size is 10. And we are performing following operation. Push 10, push 30. Then push 2 times pop, addition. 2 times swapping, 1 time push, addition. 40, 60, 90. Then again 2 times swapping, 1 time, 2 times popping and 1 time pushing, and then x pop, y pop. What is the value of x plus y? Answer it. Answer this. Okay, done. Maybe, what is maybe? What is maybe? It is not something that should be maybe. No maybe. Answer. X plus y. What is the value of x plus y? And you should not take that much time. There is no maybe. Straight away. Yes or no? Okay, let's see. Let us see. Difficult problem? Only push and pop. Difficult problem? Only push and pop. Let me take this one here. Okay. 10, 30. So there is a 10, there is a 30. Okay. Now push, pop and pop. So 2 pop, 1 push. So now 30 and 10 will be popped together. It's a function that returns some value. And now this will be popped and 40 will be pushed. Okay. Then you say push 40 one more time. So again 40 will be pushed. Then you say push 60 this time. Push 60. 60 will be pushed. Then you say push 90 this time. So 90 will be pushed. Okay. Then again you say pop and push. Okay, so that is equal to 2 times pop. So 60, 90 both will be popped, and this time 150 will be pushed. Okay, then you say x is equal to pop. So now x is equal to pop. What is the value here? X is equal to 150. Y is equal to 40. Y is equal to next pop, that is equal to 40. X plus y is, answer is 190. As simple as that. This is how they concentrate. 190 is the correct answer for this question. Is it clear to you? Is it clear to you that 190 is the correct answer for this? How are you, Speed Soul? What was your rank? What you have achieved last year? You were very regular in attending all the sessions. So, what did you achieve? Did you able to achieve something? You were very regular and you performed very well in the class. I'll not say I don't know about the examination, but you have done very well in the wall YT sessions. So, are you able to do something good? Speed Soul, 190 is the correct answer, Rita. Okay, no issue. Now let's come to this another question over here. No, address calculation I will not. The top element of the stack. You talk about this. Let's complete this one. Next question. Next question to you. Suppose the array implementation of the array is size 100. Suppose we perform the following operation. Push 1, push 2 up to push 25. Then we do 1, 2, 3, 4, 4 times popping. Then we again do 2 times pushing, and again we do 4 times of popping. Okay. So if we perform all this operation, what is the top element of the stack? Be quick and answer it. Simple question. Simple question. It's a simple question. You can answer it. Very nice. So now if you perform the 1 to 25, so definitely it will be 1, it will be 2, it will be 3, it will be 4, and up to here then it will be 19, and then it will be 20, then it will be 21, then it will be 22, 23, 24, and finally 25. Okay, this is 25. Okay, then you perform 4 times pop operation. So 1, 2, 3, 4. So up to 22 it is popped. Then you say push 26 and 27. So now you are going to push the operation here 26 and 27. Great. Then you perform 1, 2, 3, 4. Okay. So now 1, 2, 3, 4. Up to 20 has been popped. So this is the element that is top, and we can say the top element of the stack in this case is 19. Very good. So now you are consistent. 4 person has answered, and all have answered it correctly. So top element in this case is 19. Very well done. Okay, very well done. Now let's have one more simple question over here. Now this. Let's understand this very simple question. Consider two stack S1 and S2. S1 consists of 5 elements, 10, 20, 30, 40, 50. 50 is on the top of the stack. Okay. We want to pop 10 and 20, and remaining elements should be present in the same order. Okay. The means order with 10 and 20 should be popped, and it should be remain in the same order, 30, 40 and 50. Okay. we can use S2 for a temporary holding the values. This is also a stack. This is also a stack. Okay, this is also a stack. Minimum number of push and pop required to perform this. That means to achieve this. To achieve means to perform the pop and to perform pop 10 and 20. Pop 10 and 20. So if I want to perform the pop operation of 10 and 20, what is the minimum number of push and pop is needed? Think and then answer. No random answers. Okay, no random answer and guesses. Speed Soul, I am still waiting for your response, buddy. Hey, no guesses, huh? Don't guess, Nestle. Total number of push and pop. Okay, fine. Come here. So now here temporary we have to store the value. Which value? S1 and S2 is there. So temporary we need to hold the value in the S2 stack. So now if I want to pop, then I need to, I cannot directly pop the value 10 and 20. For that I have to remove all the element on the let's say top of 10 and 20. So I have to do what? I have to take out all the element from here, and I have a temporary storage in this cases. So now 50 will be popped and push, 40 will be popped and push, 30 will be popped and push. Okay. So look at here that I have removed all the three elements, and since I need to take out 10 and 20, and that is the issue with the stack, that it is always if you want something from the bottom, the entire has to be put into the another stack. So now 30, 40, 50 all has been removed. How many pop and push I have done? So here I have done 4 pop, 3 pop from S1 and 3 push to S2. Now after that this 2 will be popped. So I will get 2 more pop here in this cases, 10 and 20 will be popped. And now I need to restore the value. So again I have to do 3 pop and 3 push. Okay. So now the final answer is what? 3, 3, 3, 3, and that is 12. 12 plus 2, that is equal to 14. If you talk about push and pop, then total 8 push. Okay. Minimum number of push and pop required to achieve. Any other way you know to achieve this configuration, that it has to be in the same order, you let me know. But I find that total 8 pop and 6 pushes needed. 6 pushes required. So I'll go with 14. 8 and 6, that is equal to 14 is the correct answer. 8 pop and 6 push. So I'll answer this question as 14. But again, maybe, but simple aptitude that how many push and pop will be needed here in this case. Okay, simple. 8 pop and 6 8 pop and 6 push operation. 8 pop and 6 push. Okay, great. Now, so this is one part of the stack, and they ask a question related with this in the examination. Now, yes, we have time. Now, another part which is a stack is consist of is expression. Okay, and before we start the expression, we have to learn expression in computer. So that is evaluated by stack. The stack here in this case is that is a operator stack. So we use operator stack to convert infix expression to prefix and postfix both. Now, so I can use stack for this conversion. Okay, I can use the stack for this conversion. That is true. Without stack also we can do. Whether I am using a stack or not using the stack, both the cases I need this precedence and associativity table regardless of this, because this decide in which order we will perform. So we need this precedence and associativity table. Specifically, okay. Within that, if you have an expression and it is in the bracket, it has to be evaluated first. One time one student asked me that if I have an expression this, how should I write prefix and postfix of this bracket? Okay, because it has to be maintained in the same order. Okay, it has to be maintained in the same order. So order is 30, 40 and 50. So that order cannot be changed. Okay, that order cannot be changed. We have to pop 30 and 40 and remaining elements should be in the same order. This is called symptoms where you don't you live in your own world. Interpretation. It's not that it will be, it's not that this is the problem you will get in this question. There are many such gate question where the main problem is that you are not able to interpret it properly. Okay, interpretation is not done properly. It's not only you, that is also true. There are many students you will find, okay, I thought in that way. So you're not able to crack the thinking or crack the puzzle of what the question creator thought, and he'll give you the all information, and every information is important. So it's not that only it's the problem of you, but interpretation of the question is also one of the key aspect. Many students struggle with this. Let's not drag this discussion further. Let's come back to what I was talking about, is the expression table. This. Then unary minus, the most neglected operator that we don't consider. Okay. So when I have an expression like minus 5 plus 6, and if I ask, every time I ask the student that what will happen first, they always say plus, because they never consider that minus is also an operator, a unary operator, and it has to make 5 first minus 5. So 5 and minus 5 are two different things, and it is the unary operator that will make 5 to minus 5. Then exponentation. Exponentation is written up arrow or in this manner. Okay, in this manner, and 2 to the power 3 to the power of 5. Now understand, if it is mathematics, 2 to the power 3 to the power 5, the 2 to the power 2 to the power 3. Okay. So now the idea is that first you get 2 to the power 3, that is equal to 8, and then you do 2 to the power 8, that is equal to 512. You never do 2 to the power 2, 4 to the power. Okay, we never do in this way. It's wrong. And that is the meaning of being right associative, that if you have 2 exponentation 3, then the first thing you need to do is this operator, 2 exponentation 3. Okay, and then you do this part. So 2 to the power 3 first, and then 2 to the power 8 is 512. Okay, and that is the right to left. Then you have a multiplication, division, modulo, left to right, plus minus left to right, and equal to again right to left operator. Okay, right to left means if you say A 10, B 20 and C is equal to 30, then A is equal to B is equal to C when you say, so again it should be from the right to left, that first B should be updated to 30, then it should go and update the value of A to 30. All should be assigned to 30. Okay. So again the interpretation will be like this, this and this. Okay. This is how it will execute, this is how it will execute. 2 operators are right associative. Exponentation is right associative and equal to is right associative. Now, once you get this idea, then the rule is very simple. Okay. The rule says that if there is a plus B, for example, example I am taking, example. This is called infix. This is your infix expression. Its prefix will be plus AB. A plus B. Its postfix will be AB plus. Okay. Now this is called prefix or Polish notation. Polish notation. This is called postfix and called reverse Polish notation. Sir, will it be sufficient that if I consider only 2 operand and 1 operator, but my expression can be bigger? How will going to deal with the bigger expression with the rule only for the 2 operand and 1 operator? Your expression can be bigger. Believe me, we can handle any expression by using this, any expression. Let's start with this. Okay, which method? The direct method without stack. Okay, direct method without stack. This is called Gola method. Okay, so we will prepare golas, lots of golas will prepare. Okay, like how? So like this, operator precedence, this is 1 gola, operator precedence, division and multiplication is next, but they are in the same row table, they are in the same multiplication, division and modulo, same row, but left to right. So now division and multiplication, left will be done first and then right will be done, means each operator has to be assigned a precedence, and that is your fourth. So this is the first, this is the second, this is the third, this is fourth. How you are getting it, sir? So I am getting it from the table. Okay, I am getting this from the table, I am getting from this. Now you start converting one at a time. Okay, one step at a time. How? So let's start with 1. So it A minus B divided by C multiplication, prefix, exponentation DE. Now the rule is, once you have converted this part to this part to this is an operand. Now you treat it as a operand and you put an underline into this. What is this? This is an operand now. It is no longer a expression. It becomes an operand. Second, A minus division BC, operand, multiplication, exponentation, DE. Then third one is multiplication. So operand, operand, operator. A minus multiplication, division BC, exponentation, DE. Done. Operand. Done. Operand. Finally, one operand, operator minus, and this minus A multiplication division BC exponentation D. Done. Covered. Okay, covered. Done. Now, similarly for postfix, no difference in postfix as well. How? Now, A minus B divided by C multiplication, order is same. DE exponentation. Okay, DE exponentation, put a again underline so that it will signify an operand. Next is this second step. So A minus BC this multiplication, DE exponentation. Next, A minus BC division, operand 1, DE exponentation, multiplication. This. Write two operand and take the operator outside. Only two rule. Finally, one operand, another operand. A, B, C, division, DE exponentation, multiplication, and then minus. Sir, life was very simple with infix. Why to convert into prefix and postfix? So the answer is because of its advantage in terms of complexity. Okay, it take less time for execution. A exponentation B minus C multiplied by D plus E exponentation F. Okay, convert into prefix and postfix and say done. You don't need to write the answer. Say done. Convert into postfix and prefix. Convert to postfix and prefix. And say done. Say done. Minus plus left associative. Minus plus left associative. Go ahead. Am I not audible? Hmm. Great. Chal. Let's finish it off. Now, what is the order? So now these are two separate, anything you can do. This is one or this is two, whatever you feel better. This is your three, okay? Either A, this is one, this is two and this is three, but has to be done. Because of left associative, this is 4 and because of this plus, this is 5, okay? So now let's start converting. So prefix is exponentation A, B, done, minus since they are independent, this is and this expressions are connected with 4 and 5. So now you can do in a one step if they are connected, like A exponentation then multiplication. The next step I cannot complete, but here next step I can easily complete by writing CD plus exponentation EF. I have completed 3 steps, and reason I am able to complete 3 steps is they are separate expression. There is no overlapping of the expression. There is no dependency among each other. Like if I say that A exponentation B and then multiplication C, then this and C should be converted together. But this is not the case right now. Now this is left to right, so I'll say that I'll go left to right. So I'll take these two expression first and I sort the minus part. So minus exponentation AB multiplication CD, this plus exponentation E. Now it will be plus minus AB plus minus exponentation AB multiplication CD and exponentation E. Final answer. Same expression I can take for the postfix as well, and I can say AB exponentation minus CD multiplication plus EF exponentation. Next, left associative minus, so I will go with AB exponentation, CD multiplication and then minus, and plus EF exponentation. Last is plus, so AB exponentation, CD multiplication, then minus, then EF exponentation, plus. Done. Done. Okay. Prefix and postfix. Okay. This is an expression for you as a for homework. Complete this problem, a homework problem. We are done for today, and I'll see you tomorrow with a new topic. This is homework. These are the part we need to remember for stack. Configuration based question. Very good, huh? Very nice. Thank you very much. I'll see you tomorrow at the same time, 6:30, and we'll talk about I think Q, I guess. Okay, I think Q, but let me check once. Yeah, we'll talk about Q tomorrow. Stack and Q both. Huh? Some problem we'll do where stack and Q both are involved. Huh? Maybe some PY. Huh? Thank you all of you. I'll see you tomorrow. Tomorrow 6:30 we'll talk about Q. 6:30 PM will be have a session for the Q data structure. And some question which is coming in right now in the examination that concern both stack as well as Q. We'll talk about that. Thank you all of you. Best of luck. See you tomorrow.